Okay, this is another FRQ example. I just asked you to kind of fill it in here. This was the half sheet you were given earlier, I think 7th hour. I might have just scanned it, so I will try to get that rolling for you, make it a little bit bigger. So a local library is considering changing its summer reading program. I've picked this question because I am obsessed with the library, love the library, and especially my Tinley Park Library. So I always was in the summer reading program, pushed my kids in it all the way through high school, even though they did not like me for it, but hey, they won a lot of good prizes, and they continue to be readers. Anyways, currently, children who read at least 100 books are entered into a raffle. Facts, and some of them win prizes. Also facts. The library is considering giving prizes to all children who read 100 books instead. To gather parent feedback, the library selected a random sample, so that's of course your first key phrase, of 87 parents whose children completed last summer's program and asked which of the two possible summer reading programs they prefer. Of these parents, so that's kind of getting you ready for that last one, 63% support giving prizes to all qualifying children. Construct and interpret a 95% confidence interval for the true proportion of all parents whose children completed last summer's program who prefer giving prizes to all qualifying children. So this is your answer. So when you are like searching for context, just go back to the question. So even without an answer here, I'm going to say that the interval from blank to blank capture, we are confident that the interval from blank to blank captures the true proportion of all parents whose children completed last summer's reading program who prefer giving prizes to all qualifying children. So don't reinvent the wheel when you're writing your context answer moving forward. Okay, so hopefully you're kind of already got your juices flowing here with so this is what your FRQ looks like. This is just us really kind of making sure that you do that. But when you have the test, it's just a big blank paper. So I don't want you to get overwhelmed. Hopefully by the time we do this 100 times, you're like boom, 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 and you've got your 5. Your 5. Okay, so the procedure is a one sample Z interval for P. This pen stinks, and so does that handwriting. With a confidence level of 95%, the parameter is the true proportion. I'm going to save my own time here. It's the true proportion of all parents who, right here, whose children completed last summer's program who prefer giving prizes to all qualifying children. Okay, so that is your parameter. So we're going to go right to the check, just so that this video isn't too long. So random, okay, I underlined it, parents were randomly selected. If this was a 2 proportion, you would have to say it, each one. Okay, 10%. There were 87 parents whose children, I usually put a colon there, so 87 is less than 10% of all parents whose children completed last summer's. I'm kind of going to be lazy here. Again, not lazy, I'm just trying to save time because you probably already sped up this video if you're even listening to me on sound, but completed last summer's program at this library. At this library. Okay, I do have a tiny bit of that means that there were at least, 870, so probably, I'm off the grid here, but sometimes, again, don't get too caught up in the weeds. They're not going to give you an FRQ that doesn't move forward after the conditions. So, any old two. Sometimes that's in a multiple choice question, like, can we continue? Now, that's not to say that never, but, again, we can be pretty confident that we can proceed with this. Okay, and then large counts, we have 87 times 0.63. 87 times 0.63 is 54.81. Oh, I have my lights on. 54.81. Greater than or equal to 10. And then 87, 1 minus 6.3 is 0.37. Is 32.19. Okay, so calculate. If the conditions are met, which they are, now we can proceed. All right, so the general formula is always the statistic plus or minus the z star times p hat. Now, I used to call this q hat. Then I had to change my ways when I started teaching this. Okay, right off your formula sheet. The specific formula for this is going to be 0.63 plus or minus. Now, this is a 95%. If you haven't, again, I hesitate to say memorize, but we're going to do second inverse norm. And we want a 0.95% center. Okay, and then there's your plus or minus 1.96. Times, okay, here comes our 0.63 times 0.37 over the sample size. Okay, so be really careful, like make sure you have practiced a lot of this stuff. These can get tricky. I go inside out. So I would do the second square root of alpha F1, and then I put my 0.63 times 0.37, and then I kick it down over 87. I get an answer times, so I kind of go backwards, 1.96. Okay, so that's your margin of error. So you can either do it there. Some of you could just keep that answer like that and then plus 0.63. All right, so this is 0.731. Make sure that you're putting that on the upper, okay? I just added it. So now when I do second enter, I just kick it over there and then I subtract it. It doesn't matter if you add or subtract, but that is your lower. Your point, oh, I lied. Oh, jeepers creepers. 0.63 minus all that. So that's what I'm just going to go right here. Sometimes I don't know what I did there, but I don't want to rewind the video and figure it out. Okay, so that is my plugging in the numbers. Be very careful, lower to higher. There's my answer. I am going to show you how to find this on your calculator eventually, the whole thing. But for now, we're just going to kind of keep working because there's a lot of questions, oddly enough, about just like margin of error and like critical values. So that's something that just kind of keeps going and going. Okay, so the conclusion, we are 95% confident, and again, just to save time, I'm just gonna, kind of write this. We are 95% confident that the interval from 0.529 to 0.731, don't do this on your test, this is just me right now in the video, captures the true proportion of all parents. Now back to the question that you're going to have in front of you. So you could just pick it up right here. Of all parents whose children completed last year's summer reading program who prefer giving prizes to all qualifying children. So don't reinvent the wheel. That's all just reuse the question for context. This is the ... So don't put that on my test. Don't put that on, the AP exam. This is just me right now for my video purposes because there's a couple more parts to this question. Okay, hopefully that's good. For part B, is there convincing evidence that more than 55% of parents whose children completed last summer's program prefer giving prizes to all qualifying children? Explain. Okay. So now they're trying to see, like, look at your interval. They're trying to see, can you interpret an interval, a confidence interval? A confidence interval, you capture it or you don't. Okay, that's why it's not a probability. It's in the interval or it's not. Okay, so more than 55% is not. So the answer straight up is no. So remember, make sure you first answer the question, yes or no? No. And here's why. Some of the plausible values in the confidence interval are less than 0.55. So there's not convincing evidence that more than 55% of parents whose children completed last summer's program prefer giving prizes to all qualifying children. Again, that is, you're interpreting your interval. Did you capture this particular proportion? So they asked if 55 did convincing evidence more than 55%. You have some of these that are less than 55%, so no. So not everybody's on board. Okay, so again, saving time. And part C says that the library selected a random sample of 73 parents now whose children did not complete last summer's program and found that 57% preferred giving prizes to all qualifying children. So there's lots of thoughts here, right? Like this was a random sample of 87 parents whose children completed it. So they might feel differently than these 73 whose did not complete it. Okay, so people feel very differently about their involvement and who should be involved, right? Depending on their own particular experiences. So hopefully it makes sense so that when you construct another 95% confidence interval for the difference in proportions of parents who prefer giving prizes to all qualifying children. All right, and now here's the key. They want with children who completed minus children who I'm just going to put did not complete. All right, now we can assume that all conditions have been met. I love when this happens. So we don't have to go through random 10% large counts. We just have to go through and determine if I'm going to call this P1 and this P2. Okay, so the probability that, well, nope, that's a lie. It's not a probability. It's a confidence interval. So we're looking for the confidence interval of P1 minus P2. I'll zoom in a little bit. Okay, plus or minus the Z star of, now here comes this new one, this new, it's not a standard deviation, it's a standard error of P1 hat, 1 minus P1 hat. We did this a week or two ago, over N1 plus, okay, variances add. P2, 1 minus P2. Mrs. Buck used to be able to call this PQ. I think it's easier, but alas, I'm not ruling the planet just yet. And I had some white out here. Sometimes the mathematic really starts to take over because I'm writing way too big, but that's okay. It's far, far away. All right, so they wanted us to go in the order of completed. So that was 0.63 minus not completed, 57%. Okay, hopefully you're with me. Plus minus, still 95%. I'm going to go in a different color here just to make it pop a little bit, and then I'll scoot up. Sometimes I'll cut this. Well, I'm just going to get my white out. Stay tuned. Maybe you can work ahead. Okay, so that just cleans it up a little bit for me. Okay, so this is going to be 0.63 times its Q value, 0.37, over that number. So that number is 87. This is where you have to be careful. This is the one we did in class was with prom, juniors and seniors. Plus, I have to remember to turn my phone off when I do these. 0.57 times 0.43 over 73. So that number is up here, 73 parents. Okay, so this again, if you want to pause the video, or if you already worked ahead of me, this is, I'm going to do this first. So I usually just do one big giant second square root, alpha F1 for this guy. So 0.63 times 0.37, downstairs is 87. Kick it over, plus alpha F1, 0.57 times 0.43, downstairs 73. So I'll get that answer, okay? So that's 0.077 times 1.96, my critical value. So the margin of error is 0.1522 and some change, okay? So this is what I'm plus minus this guy. So right now I'm just going to do 0.63 minus, I'm sorry if I'm off the grid, 0.57, so 0.06, all right? So you can do, if you do second answer, it's going to give you that again. I know sometimes a lot of you guys, your calc knowledge is so-so, depending on who you had for math 1, 2, or 3. I used it a lot. So this is 0.06 plus. So I always do the plus first. So again, you have to be kind of careful. 0.212, and then the minus, 0.06 minus 0.152286. This is the part that doesn't, I don't want to say it doesn't matter, because of course it matters, but you know, a couple of you were asking me where to round. You've got the idea. Your interval is going to be what it's going to be. Okay, so that is, that they didn't ask you to interpret this, okay? But I will just tell you the interpretation a little bit is that because 0 is in the interval, so this went from negative to positive, 0 is in the interval, so that means that within that interval, there's no difference in the parents' thoughts, I'll say, on this issue. If they were doubly positive, then you could say that the parents who completed felt strongly. If they were double negative, then you could say that these guys felt more strongly, right? Because that's why the order matters, of course. Order matters. All right, so that's part A, B, and C. So I will turn this video off if you're even still with me. I hope so. Thanks for watching and learning.